this video, I will show you how to link a 3D character to Fantasia to extract knowledge from Neo4j and reply to the user using speech synthesis and lip sync. To synthesize speech, we will be using the Amazon Polly component included in Fantasia, as Microsoft Azure does not provide lip sync data. The nodes to use Azure TTS, however, are pretty much the same as for the AWS component. So as you can see, I reorganized a bit the blueprint from the last example just to have a cleaner version, and I'll walk you through it. First of all, let's take a look at the components that we have now. First of all, I added a mesh component because this time we want to have a 3D character that provides answers. And we have an audio component which will play the voice of our character. We have the Azure NLU component from the last example and the Neo4j component, of course. And we have an AWS Polly component that refers to the Amazon TTS service, and a TextToLipsync component that is a component that you can download from the marketplace and that will handle lip sync and audio playing. Now let's see our character here in the viewport, and this is Jason. Jason is a Genesis 8 character I imported in Unreal, and I played around with the materials so that now he looks like the son of Dr. Manhattan and Cortana, although both of them deny knowing anything about him. And Genesis 8 characters come with a set of morphs, facial morphs, that we can use to control lip sync later. So let's go back to our blueprint and let's jump into the details. To configure the AWS Polly component, you need to set up the two keys that you're provided with when you create your service on the Amazon portal. Then you indicate the name of the voice that you want to use and the type of voice. In this case, we're using Joey, which is a standard English voice. Now let's move in the blueprint. Here we have an initialization phase in which we connect the audio component to the TextToLipsync component, so that when we hit play on the component will know on which audio component to play the voice. Here we have a custom event called listen that starts natural language understanding, as in the last example. And I also put here a timeline to turn the color of the eyes of Jason to green while he's listening, and to turn them back to normal when he's not listening anymore. So just like in the previous example, we will get an intent with recognized entities from Azure. Here is the same situation that we built in the last tutorial, with the only difference that right now, just to clean up the blueprint a little bit, I created a map of queries so that for each intent that can be recognized by Azure, I have the corresponding query. These are the same ones from the last example. And I also set up the parameters that are needed to make these queries run on Neo4j. After submitting the query, the eyes colors will become normal again. So now let's go to the management of the answer and to building the actual sentence that has to be synthesized by Amazon. Here we have the same setting from the last time to obtain rows from the results of the Neo4j query. And we want to build a first part of the answer depending on what was asked by the person who's interacted with JSON, followed by the list of results that we have from Neo4j. So the first part here consists into getting the one and only entity that we're expecting from this kind of a query. This is simplified for this example. And we have two possible strings that we want to start our utterance with, depending on the intent. So either we want to have an utterance that is coherent with the user asking about the movies in which a certain actor appeared in, or we want a list of actors listed because we asked for a movie. We will choose either of the strings depending on this condition. So if it is not get acted in, it must be get actor movies. And in this case, it is sufficient to work like that. So we have the first part of our answer. Now let's build the second one. It is based on the same cycle that we built to collect the results that are coming from Neo4j in the last tutorial. We get the values and we build a comma-separated list that is appended to answer. So in answer, we have now the string that we want to synthesize. And we simply put it in the SSML input of the TTS start function of the AWS component. Now this accepts input in SSML format, but in this case we will use a simple string and it will work in the same way. In a more advanced tutorial I will show you how to use SSML to better control the resulting utterance. The ID of the returned utterance will be answer, and we want to get lip sync. So now what we need to do is obtain the result of this and play it. When the synthesis is ready, the component will fire a synthesis ready event. And in this case, we have the ID of the synthesis that is ready. We can use the getLipSync and getSound functions to get two different structures. A structure here, a TTS timed struct, and a sound wave. In order to get information in the format that is needed for the text-to-lip-sync component to move the lips coherently with the sound, we need to build the appropriate structures. So here, for each information, for each object that is contained inside this array of TTS time structures, I build the corresponding structure, lip sync time data, that is needed by the text-to-lip-sync component. This simply takes the timing of the first vsim that is returned by the AWS component and the timing of the following one for each vsim returned by the AWS Poly component. It divides this time instance by 1,000 because it needs to put them back into seconds, while AWS works in milliseconds. So by appending the time offset and the end time of the current phoneme in the loop and of the next phoneme together with the actual symbol representing the vsim here, we build an array of lip sync data structures that are used by the text-to-lipsync component. This works for all the elements in the array but the last one, because the last one doesn't have a following one. So here we manage simply the last component and we add it to the array. Now we have the information that is needed to accompany the sound, but we still need the sound itself. We get it using the getSound function here, and we have an array here that simply uses an empty array to control the notifies. We're not using notifies here. I'm not using this one here. This was temporary. The lip sync data we just built goes into the subtitles input here, and the sound is linked to the voice asset. This is assembled into a lip sync phrase, which is the final structure that is needed by TextLipsync component to actually play the sound. So we call the speak function of the text-to-lipsync component, and we pass this structure that contains the sound, the information that is assembled by collecting data from the lip sync that is provided by AWS, and we play the sound. So the only thing that we need now is to actually start everything. We need to call this listen custom event, and we'll do this from the level blueprint. So I created an action and I linked it to the spacebar. So whenever I hit spacebar, the blueprint here, the level blueprint, will call the listen event on the instanced JSON in my level. The listen event will make JSON start listening and turn its eyes green. When the intent has been interpreted, here the correct query to the Neo4j database will be chosen and assembled together with the parameters, and the eyes go back to normal. When the answer from Neo4j is ready, we assemble the first part of the answer. We append the list of results that we get from Neo4j, and we use this to start the synthesis on the AWS component. When this is ready, we first convert the structures that are provided by AWS Poly component into the structures that are needed by the text-to-lipsync component. We get the actual sound, and we combine this information into the final structure here, and we give them to speak. But one final touch on the audio component, I set up a source effect chain that contains another effect that consists of a modulator acting on 80 Hz frequency. This way you can get the voice coming from Amazon, and you can dynamically modify it inside Unreal to apply effects. In this case, I want the final voice to sound a little bit like a robotic one, because JSON is a hologram, looks like a hologram. So the actual voice coming from Amazon will be passed through this effect before being actually put as output on the speakers. So let's see what happens. So here we will now play our level. Word of a warning before. There is some latency when the answer is provided by Amazon. So my suggestion is to pre-synthesize as early as possible the possible answer that you may want to give to your user, and only use speak when you decide to actually say something. So use pre-synthesis as much as you can, because there is a significant latency between the instant when you request the synthesis from Amazon and the time that you actually get the synthesis. So you need a bit of planning about that. As a reference, this is the setup that I'm using for the text-to-lip-sync component. You can apply this to any Genesis 8 male character. And let's see what happens now. Who acted in The Matrix?
People who acted in The Matrix include Emmy Lyfrom, Hugo Weaving, Lawrence Fishburne, Carrie-Anne Moss, Keanu Reeves.
In which movies did Meg Ryan appear?
Movies Meg Ryan appeared in include Top Gun, You've Got Mail, Sleepless in Seattle, Joe vs. the Volcano, When Harry Met Sally.
So this is the final video of the basic series tutorial. I showed you how to build a very simple embodied conversational character that uses the example tutorial database from Neo4j to provide answers about the movie domain. Now I'll be working on linking Fantasia with MetaHumans, of course, because the natural consequences of having Fantasia is to use them with MetaHumans. And I'll be publishing advanced tutorial from now on to cover more detailed and deeper examples using some functionalities from Fantasia that were not included in this first series. So thank you everyone for following these tutorials. Please download Fantasia, and I hope you have fun with it.